I do not know where the camera angles are though. Alright, welcome to the second Filabot Live on October 12th. Today we have some pretty cool stuff that we're going to be doing. I'm getting some, what's going on? Am I not in the shot? We good? Today we are doing a few pretty cool things. The first is PLA, and we're going to give you a demo of that on our extruders, which are running behind me. We have a new material of the week, and some chemical tests, and then any user questions as they come up. We're also streaming Facebook Live. Is that working? Nice. Which is our first Facebook Live. So, where do we want to start? Let's start with PLA. PLA is one of the most common 3D printing materials. NatureWorks PLA is, well, NatureWorks in itself is a company that's been developing PLA for 3D printing. I have an old video on our YouTube channel that went over two grades of PLA, a 4043D and a 3D850. Now we have, I don't know which one it is. Well, one of these. I don't think. Oh, they are? Oh, nice. So this is 3D870. Let's see if we can get 3D870. This is their newest one, released a few months ago. And we have some test prints. Later in the video, we're going to go in and play with those and show you the strength. One of the biggest things between all these PLAs is the first one, the 4043D. Where's the label? There we go. Has this yellow tint to it, while the other new grades do not have that yellow tint. So if you're just extruding and printing with the natural PLAs, the newer ones are going to have that clear whitish tone, while the older 4043D has that yellow tint to it. The Filabot Original currently can only do the 4043D, while our EX2 system can do all of these grades of PLA. 3D870, man, I really should have got some numbers on this, but 3D870 is super strong. I believe it was about 7 times as impact resistant. I'll fact check all this and we'll put it on the video description. I believe it was 7 times more impact resistant compared to the 4043D. So really cool stuff happening with PLA. It's becoming a really, really good engineering grade plastic. And it also is the most common 3D printing material for 3D printing. Man, my head is going to be cut off in half of this, isn't it? Bummer. Alright. Moving on to another plastic that we have on the table. Let's see if we can zoom in here. Is this new material. This is another material from SK Chemicals. This material has some really great chemical resistance. I do think there was a spelling error on their data sheet because it says twice that it has this outstanding chemical resistance. So we'll verify that. And we also don't know what chemicals it's resistant to. So Josh is going to assist in a quick little test. What we have is a little fish that is made out of this material. Oh, I didn't even say the name of the material. This material is TC100. Again, from SK Chemicals, one of the 3D printing line materials. So we have this little fish here, printed from it. Oh wait, we're not putting the fish in.
No, the little cups here.
Okay, okay. Yep. So I'm going to zoom out a little more. Cool. So we have 2 jars, 2 cups printed from the TC100. And we have acetone, which is pretty, what do you want to call it, mean? Pretty aggressive chemical. Yeah. Aggressive chemical. And then we got this one. I don't think I can pronounce it. Tetrahydrophora. Yep. this stuff here. See if we can.
Known to dissolve PLA.
Which it kind of worked when we tested it.
Yeah, it wasn't great.
It wasn't great, no. So we're gonna pour, well, do we want to pour it in or do we want to drop it? Might be cool if we drop it.
Yeah. I mean, it's not instant. No.
Yeah, that's true. So yeah, we don't know if this is gonna do anything right now. What we're gonna do is put it in here and just let it sit, and then next video we'll let you know the results. Zoom in. Dun dun. Do you see that transition? Really nice. Okay, so acetone and the tetrahydro stuff. If anyone from OSHA is watching, we do have that in our safety data sheet folder. Okay, let's drop them in. Let's do one at a time, or as many as you want. Ah, man, this stinks. So, good call. Good call. One label A for acetone.
Yep.
T for that long word. It's not. Oh, is it changing color already? Let's see, I'm going to swirl it around a little. Why not? Make this a little bigger. Okay, let's. It's not really. It's got some like white powder at the bottom, or like this frothiness to it. So yeah, we'll let that sit for a while. The acetone one is looking pretty clear, like normal. So we'll let that sit for about a week and see what happens to it. Man, I don't like how my, hang on, I gotta adjust the camera. Bummer. Okay. Cool. Any questions from the audience yet? Audience? None?
We got a thumbs up.
Oh, cool. Thank you for the thumbs up. That's exciting. Yeah, last week, if any, well, actually nobody tuned in. It was just us watching live video. Yeah.
It was a test.
It was a test.
There's nothing wrong with that.
Yeah, we had no clue what we were doing. Okay, so moving on. What you see in front of us is our Filabot extruder setup. We have our Filabot EX2. We have our Filabot air path. And we have our Filabot spooler. This whole system here, we haven't determined if I'm a good cameraman yet, so forgive me. This whole system here is what makes up our extrusion line. We have PLA pellets. These are the newest grade of PLA pellets, the 3D870, being extruded. We're extruding at a 180 degrees C. It's coming out of the extruder onto our air path system. This system is relatively basic, but we've engineered it to look really cool and function at a very high performance level. Bunch of fans, and we use these sweet little magnets to guide the filament as we go down. You can see, it might be hard in this video, maybe we'll do a close-up later, of the filament. It's more transparent, and then as it cools, it turns more opaque. So after the air path comes to the Filabot spooler. Spooler unit is what helps dial in the diameter of filament. So what's happening is these two wheels are pulling the filament out of the extruder. The nozzle on the extruder, I think, is larger right now. So it's a little bit larger, and what we're doing is it's pulling it down, and that pull down is what allows for that really high tolerance filament to be made. So the wheels are pulling, and then we come to our traverse mechanism. This system takes the filament and passes it back and forth on a spool, and I showed a little bit of that, like just a spool, on the last live video. Then it goes on the spool. And that is filament being made on a Filabot system. The EX2 system works with all PLA grades that we have currently on our site. Filabot Original only works with the 4043D. Over here, we have a spool that we just previously made of the 3D870. That's 50. Okay. So, grab this real quick. We have a beautiful Printabot. If I can zoom in. Beautiful Printabot printer going right now with some custom tape modifications. Printing out a small little base. I don't know if the other camera can see it. Did Kevin just... Why doesn't Kevin like come out and help? Okay, we will bring that up. Oh no, I don't know which one that is. Anyway, right now we're printing a base with 3D850. Second newest, or no, is that? Well, that's the new old PLA. And then our Filabot Systems right here is extruding the 3D870. And we'll be printing, or we already have one. Oh, we already have a base. And we're going to do some squeeze tests. So Josh, you need your muscle. Okay, we're going to go up to the camera here. Kevin's helping by commenting. Oh, nice. Oh, we got a comment. Yay!
From Dean, he said, that's pretty noisy. What is the decibel?
Have we ever tested that?
I think right now it's around like 60. So conversation, I am talking a little bit louder just to make sure the camera mic is picking up what I'm saying.
And background noise always comes through louder
Yeah.
over a microphone.
Yeah, so it's probably around 60, 70. You know, if the extruder is running faster, it's going to be at a higher level. You know, if you're typing on a computer and this is next to you, it may get a little bit annoying. We have designed it to be as quiet as possible, having the full enclosure around all the systems. It's really hard when you're just pushing all that air through our fan system. I mean, if we were to shut that off, it would really be pretty quiet. Maybe towards the end of the video, we'll shut it off and we can show you kind of the change in sound. Thank you very much for that question. Okay, PLA. 3D850. Oh, you got your gloves on too.
I am.
He's ready. All right, we're gonna come right up here, Josh. Might want to step over there. Now watch the table. That tetro. So this is 3D850. Do you have safety glasses on? Okay, good. It might be a little hard for that camera. And then we have the 3D870. So let's do a squeeze test to see what happens. It actually, okay. Well, that's good that it broke. Come up a little more. Yep, right there. So 3D850, still pretty strong, a lot stronger than the 3D8, or excuse me, 43D.
Yeah.
All these words, yeah, all these, are they acronyms, I guess, or grades? They're so hard to remember. So yeah, it's kind of like, it's kind of flexible, but it will break. I can't even, I'm just going to put that down. All right, so this is the, wait, this is what you can, this is the 3D870.
Yep.
So the newest grade of PLA that NatureWorks has. And it's not breaking. It does look like it's like the plastics are getting white.
It stresses.
Yep.
but, yeah, it doesn't snap.
So pretty good. Now it's not a very scientific test, as we know, but that quick little demonstration should show you that the 3D870 is a lot better for some conditions. I do believe the 3D850 and 3D870 both have a higher heat deflection or heat deflection temperature. They resist heat better.
Yeah, in the 40, definitely.
Yep. We have all these grades of pellets on our website, and we do, I believe we have 4043D and 3D850 in filament form. But we don't have the 3D870 yet. Cool. Do we have another question? We have what? Nice. That's cool. Thank you for tuning in. Let's, well, actually, I think we're good to show the system shutting off. Well, I want to see what's happening on the computer. Oh, is it Kevin? So Kevin is a Filabot team member who, for some reason, is helping with our comments. Oh boy. Okay, Josh, let's we're gonna shut the system down, and we'll show you how quiet it is. It will be a change, and like it was mentioned, the background noise will always come louder, but our systems run around 60 to 70. We'll get an app and test it and get some real numbers on that. All right, ready? We're gonna shut it down. And it gets really quiet. We do have a dryer running in the background, pellet dryer. Cool. Are there any crickets? So Josh is taking a spool off. Are we gonna print with it?
If the printer will warm up in time.
Sweet. I'm gonna get this filling now for you. Actually, let's do each system. That would be cool. And show the decibel levels. So I'm going to start with the extruder. So we turn it on. We want it to be up to temperature, which it is. I'm just going to turn it on for a second, and you'll hear the noise. So that's how loud the extruder is. Not really raising my voice. The air path. This is probably the device that makes the loudest noise. So that probably makes the loudest noise. Again, using my normal voice. Okay, I guess I am raising my voice a little bit, just to be heard. And then we have the Filabot spooler. So that's more of a low speed. Is it okay if I change the speed, Josh?
Yeah, go ahead.
So then we'll go up to kind of the max speed. It's going to fly away. So, pretty much comparable. But those are the sounds of each machine. It's kind of a constant noise here when we're running these machines. So Kevin did bring up a point of colorants. Can we quickly grab those? Why are we laughing?
Because
Great.
Steven asked a great question.
Oh no, Steven. What's the question? Is it one we have to repeat?
It's not inappropriate.
Can we say the question?
He said, so where do I get a sweet Filabot shirt to join you guys looking like studs?
Thanks, man. I like it. Is he? What camera is he on? Is he on camera 1 or camera 2?
He's on this one.
Oh, okay. Thanks, Steven. We'll get you on. Are you gonna? Yeah.
We don't have, do we have shirts for sale on the website?
Not yet.
I think we need to fix that.
Go on, maybe.
Oh yeah.
You want to push some filament through there to get the 50 out?
Shout out to Brook Drum at Printabot. You're using your printer. I'm gonna get it going with some 3870.
Yeah, that's 70.
All the filaments look the same. You know, I mean, it's filament, it's wired. Okay, sweet. It's going again. All the PLAs that I mentioned pretty much print with the same simplicity. There's really no changes you need to make to your printer for each of them.
Those are the same printer profile for both of those.
Oh, so Josh just mentioned that it's the same printer profiles for settings for bed temp and hot end. Everything. Wow. So it's very similar printing. but you do get that higher strength. Oh, you're in the video now.
I got shit.
Where's your stud Filabot shirt?
You haven't given me one yet.
Ah. Cool. Oh, we don't have to run colorants if you don't. You can give just a quick overview. Okay. Here, you want to talk about those real quick? The mixture ratio. I'm gonna grab.
So yeah, for our colorant, we mix with PLA 2% to every pound, and ABS we mix 4. We do have a mixer that we use, but we don't have that set up. Yeah, that's how you make colored filament. You just mix it in a bag and send it through the extruder, and it comes out different color.
We have little colorant baggies. This purple, orange, all sorts of different colors. The process for mixing colorants is also similar to like additives. So we've been playing with a bunch of additives that will give the materials different properties. So if you want an anti-static ABS, PLA, we can add that in, which is pretty exciting, and mixing it the same.
What's the ratio? Did you mention that?
Oh.
Of the colorant?
Yeah, PLA is 2% to every pound, and ABS is 4.
Was Kevin watching that on colorants? Hey, Kevin! Okay. Guess he's tuned out.
I'm trying to respond to the fillet.
To the what?
To the fillet.
Nice. Josh, do you want to try the color?
Yeah.
Okay, cool. So, Josh is going to show us two things. One, he's going to show us how colored filament is made. And we have PLA. Do we know what grade?
Yeah, this is 870.
We have 870 with a, is that orange?
Yeah.
With an orange colorant mixed in at that 2%. So we're going to show you how to do that. We're also going to show you how our systems get set up. So, how does the filament go from this tangled, let me zoom in on that. How does the filament go from this, over this, and to the spooler? Oh, do you need any more spools? No, we got one. All right. Take it away, Josh. I'll try
to change color.
Oh yeah, we gotta do that. So right now, the extruder has plastic, in the barrel section, and we are gonna purge it out, and we're gonna get this clump of PLA that's not colored. So we're kind of waiting for it to. Oh, we have camera inception. Waiting for it to change color. Oh, there's somebody behind the table. Still waiting. Takes a little while to change color. I wonder if it's like just taking longer.
We turned it on by emptying the barrel, so the barrel's full.
Oh, we just poured it. Yeah. So, there we go. There we go. I can't get the camera on it. Our Facebook camera's in the way. Okay. Sorry. Good Good job, though. Good job. All right, Kevin wants us to weigh that. Does Kevin get to say if he's like, he's not even here? Yeah. Kevin, help weigh it. So, it's coming out of the extruder. Created this little nodule that Kevin is going to come out and weigh. Josh is passing it through the air path, dialing it in. I think it's got to get off coated. We lost the color, it's going to come back in a second. Kind of surging with color as we do that color change. So you'll notice, do you have it on the spool yet? No? Could you step like sideways? So while Josh dials in the, Kevin's going to go weigh that. There's Kevin. There's Kevin.
Oh, we've already met Kevin.
Oh, okay.
Through the window.
So while you dial in the settings of filament, oh my gosh, you can have the filament running off the edge of the spooler and not on the spool. And then once you get it to size, you can put it on the spool. So Josh is doing that right now. Adjust this real quickly.
1.2 ounces.
1.2?
Yep.
That 0.2 is probably the orange. Can I see it? So the purging takes about 1.2 ounces, and this really isn't waste unless you have a way to grind it up.
Well, you could have just kept it on the spool.
We could have just kept it on the spool. But this is what it takes to, I've had some customers ask like what it takes to change over. Like if you're going from an ABS to PLA. So it's about 1.2 ounces, which is this right here.
Could depend. You might have some clabs there in the middle.
Yeah, some clabs. Making some crazy mixtures. So bam, there you have it. We are making filament. Orange filament. That's how simple it is.
That's how simple it is for us. We're trying to help everybody.
With our system. Boom. Okay.
Josh, can you comment on this method? Yeah, it's not a very good method. No.
Oh, hang on. Let my camera catch up. Alright. What is this method?
Yeah, it's not a very good one. It's just using a pair of calipers. It seems to work though. Yeah, it works alright. Best way really to figure it out.
Nice.
It looks like you had some lighter.
Yeah, I think like when you started, it's kind of cooked down.
When we stopped it, it was full quick.
Yeah.
We didn't really get.
I think Kevin's gonna have a shirt on, a different shirt for. I mean, hopefully you have a different shirt on every day.
I have a Filabot shirt.
That's okay.
I'm not really just wearing this. Hey, I'm shipping a motor today.
Oh, Kev, we got this material here. Oh, my camera's not wide enough.
Oh, is that the chemical stuff?
Yeah. So, you know, they didn't give us much information on this TC material. It says
Oh,
it's.
look at that. It's like little bits are coming off. Can you see those in the video at all?
Oh, you gotta get this way lower.
Put it
Camera.
down and they'll be able to get it to focus better.
Keep going low, Kev. This is the red box.
Whoa,
Yeah.
it's so delayed.
Yeah, it's a little delayed. So you can see it's
There's little
falling
bits,
apart.
Yeah, there's little bits falling off of it.
Right.
You can see them on the Facebook camera.
So
That's the tetrahydrofuran.
Ah, Kevin knows how to say it. Kevin, can you say it again just to...
Tetrahydrofuran.
Nice.
It's like, yeah, it's like fur on.
Nice. And then we have it in acetone as well. That doesn't look like it's doing anything yet. But it looks like the tetrahydrofuran is going to...
I don't even know if that's how you say it.
We got a
I'm just saying
question.
fast.
Spooler uptake speed.
You'd have to measure to see it. I mean, it depends, right?
Well, right now,
What's the maximum?
what's our range?
I
Start
think
with that.
I think at maximum it's around 500 inches per minute.
Right.
Yeah.
And then
It's not nearly that right now.
No.
The traverser's not on.
There it is.
Oh.
I was
It's
playing with the
fast.
traverse
It's
speed.
slow. It's going really slow.
I think we answered that question. It's the max uptake is 500 inches per minute.
I'm gonna turn it up a little bit.
Cool. Cool.
We want to have an auto traverse in the future. Because the speed of the traverse actually needs to change as the diameter fills up. Right now you just have to adjust it manually. I like to keep everything manual.
Simple.
It's
But-
good for like stuff that has a lot of different variables to it, different speeds, different diameters.
All right. So, do we have any other questions? Oh, we got what's this one?
That's the one we just made.
We just printed another 3D870 with the filament we made in the first section of the video. That's exciting. Very exciting. Any other comments, questions, concerns? All right, I think that concludes it for the second Filabot Live. Thank you for tuning in. And I'm going to try and shut it off a little more cleanly than last time.